Hello, everybody, and thank you for joining us, Lighting Design Lab, for another webinar offering on our webinar series. Today, we are going to be presenting What Wrong? My name is Armando Berdiel. I am the Technical Development Supervisor at Lighting Design Lab. I'm going to be joined by Shawn and Daniel Salinas, two veteran titans of industry that have for sure forgotten more about lighting systems and projects that I know at this point. And I will be properly introducing them in a couple of slides. But let us welcome you and invite you to the proverbial fireplace discussion where we'll be sharing a couple of lessons learned for projects that did not end up the best way they could have been. A little bit more of an informal panel-based presentation rather than a lecture that we sometimes deliver. So bear with us, and you'll see it should be a great time and a lot of good stuff to learn as well. A couple of ground rules as we're going through this webinar. You'll notice everybody's going to be muted, and we would still love you to engage with us. In order to do so, use the chat option at the bottom right-hand side of that webinar panel. We'll be able to see your questions. We'll have purposeful times where we stop and see if we can answer and address some of your questions. So we'll have one online poll just to see who is out here in the audience. Please participate. It'll make the experience all the more curtailed. After the webinar, there's going to be a 30-second survey about how this experience was for you. Please ask that everyone fill it out just to know, hey, how amazing we were. Also, a video recording will be found on our YouTube channel, and the handout, a PDF handout of our slide deck, is going to be posted on our website as well. If you want to further engage with us, please email us, and any questions, comments, we'll be addressing them as soon as we can. Some housekeeping items, just ensuring that everyone's aware, Lighting Design Lab is very much a part of and powered by Seattle City Lights. We are all City of Seattle employees at the Lighting Design Lab, and we are very happy to be working alongside to provide this education in the region. Also, this webinar is sponsored and brought to us by the Northwest Energy Efficiency Alliance through their Better Bricks brand. So thanking our sponsor for today's webinar. Also, we work with many strategic partners, be they be energy efficiency organizations, government entities, private industry. So it takes a village to ensure that, hey, we got to beat that toggle switch. We got to ensure that we're going to LEDs and ensuring that we're providing the best experience for tenants in different spaces. And we like to work with all the whole sphere of market actors in the lighting industry, trade allies, installers, contractors, our design allies. We think architects, building engineers, designers, and end users. Think of facility managers, building operators, and ultimately the tenants of spaces to ensure that, hey, like if we can provide education and awareness on connected lighting technologies across the board, we want to help and catalyze the market transformation of these technologies. And what we do with all of these people are we deliver education and training such as these online webinars. We evaluate technologies, emerging technologies by doing pilots and demonstrations. We develop tools and resources such as best practice guides or resource videos. And we serve as information aggregators. We keep our ears close to the ground and can share the latest and greatest with our audience. So again, I'm going to be joined by two titans of industry, and I want to properly introduce them. Shawn, Senior Lighting Designer at the Lighting Design Lab. He has been working for more than 30 years in the lighting industry as an architectural lighting designer, instructor at the University of Washington, daylight and sustainability specialist. And he's a lighting control system consultant and theatrical designer, wearing many hats. He has taught and consulted on many sustainability issues, lighting and daylighting for the Lighting Design Lab and the University of Washington's Architecture Department. We are also joined by Daniel Salinas. And he has been in the electrical industry for 42 years, beginning as a residential lighting consultant in '78, quickly progressing to showroom manager and eventually to commercial lighting designer and consultant for design build projects. In 1987, he joined the Nelson Electric as senior designer and project manager for lighting design and control systems. The breadth of his design and project management experience spans both commercial and residential projects, specializing in complicated installations with new techniques of constructability and ease of maintenance. Commercial lighting control design has been his passion, where working with integrated technology is a requirement. He has received 2 IES North America IIDA International Awards of Merit for his work on special project applications. In 2015, Dan retired from Nelson Electric to found his own Salinas Lighting Consult with the idea of expanding the concept of holistic design of lighting systems. And also, he is a past president of the National Illuminating Engineering Society for the years of 2013 and 14. And now I thoroughly regret introducing them way before myself. Again, my name is Armando Berdiel, Technology Development Supervisor at the Lighting Design Lab. I am responsible for evaluating emerging technologies, contributing to the lab's education and training curriculum, and facilitating industry engagement. I have a background in computer science and business, a little bit more of a concentration in engineering management. Began my career with more so a controls system support role, transcending into commercial project management, and ultimately worked for a channel partner on the Northeast retrofit market, wearing every hat from auditor to product developer, product manager, commissioner, installer, and maintenance on projects as well. But enough about us. Wanted to ask who is out here with us today. So if we can please, I'm gonna have a quick poll just to see who's joining us today. So please participate. I wanna see which most closely describes your role. And thank you for everybody that's already voting and joining us. That's a nice, pretty even spread. 2/3 of everybody's been voting. All right, thanks again. I'm gonna keep it 3 more seconds. All right. So again, pretty even spread. Thank you for our utility and government folks for coming in as the majority, but a couple of design allies, trade allies, and energy efficiency organization professionals. All right. A nice, pretty even spread. Very happy with this. So let's officially get started and set the stage. What are we going to be looking to discuss today? Excuse me. So ultimately, we wanted to identify common lighting system design and implementation pitfalls and how. Let's understand the why and the what can go wrong through real world examples. And as a bonus, you can get us laughing at ourselves through projects that we, some way or shape or form, did not complete successfully. And ultimately, and more importantly, understand and leverage strategies to proactively overcome obstacles you can find. Also, at the end or the last portion of this webinar, we want to invite you to share some of your stories, your what went wrong. We have some time at the end where we want to invite you to, through either in chat, or if you are feeling brave and excited enough and want to jump in and share a story verbally, we can do that as well. So if you have something in your mind that you want to share with us, hey, at the end, we want to have the opportunity to do so, and we can have Shawn, Dan, or myself comment and discuss these projects as well. When we look at this in the construction phases, and lighting projects are no different, there's a lot of room for error. You know, from the time where you're getting your business requirements and writing some conceptual ideas and a piece of a napkin, through all the way where you're, you know, commissioning your building and doing post occupancy evaluations, revisions, optimization. A lot of time, a lot of different elements to the project phases occur. Again, a lot of room for error. And Dan, Shawn, and I sat down. We were talking about, hey, what are some of these common pain points where you can get the obstacles or get trumped up on projects? What are these common themes where if you're not proactively thinking about these, the project can more surely fail? And we arrived at 6 main themes that we understand are the more common pain points in projects lifespan. And those are constructability, not adding controls to a project, maintenance and the ease of maintenance, cost, and usually the focus on upfront costs rather than the longevity of a project, design expectations, and not enough stakeholder engagement. And that's always how many stakeholders. So each of us are going to talk about a couple of these topics very shortly. But however, every project, when one of these elements is going wrong, they can get very intertwined. A project will usually have more than one of these items as a factor if it's a success or failure. So through our stories, you'll hear multiple examples of how these come together, but these are the 6 themes that we want to more so discuss. We also want to present a couple of potentially proactive solutions, such as your owner's project requirements, having a solid basis of design, ensuring that you're talking to the right people, the user groups, recommenders, influencers, having a very clear sequence of operations or control intent for your spaces, ensuring that you prioritize post-occupancy evaluations, and obviously your system optimizations. So we'll be looking at how we can proactively think about these things, and rather than be trumped up when the issues come on. One potentially proactive solution that I want to bring up, and bring up in the sense that when we were doing projects, it was not necessarily a readily available technology. But when we think about these common pain points for projects, this solution, this proactive solution, actually takes great care of many of them, and that is the Luminaire level lighting control technology. It is an emerging technology, part of what we want to call our network lighting control architecture. But your Luminaire level lighting control, or your LLLC, is what you consider your smart fixture. If you see that one in the middle, your fixture with your integrated sensors. And these fixtures, the smart fixtures, they have a couple of properties, and these are they are individually addressable. Each fixture can be its own zone or group with other zones. And the beauty of it is you can group and regroup without having to change any wiring. Each fixture is going to have an integrated occupancy and daylight sensor to monitor occupants as well as the daylight level. So you do not use electrical light when you don't need it. Each fixture will be continuously dimmable rather than switched, or that bi-level switching, as well as networkable. And that doesn't mean that each fixture is going to have necessarily an IP address. That just means that each fixture can communicate to be reconfigured in an easy manner, not having to, again, change any dip switches in the ceiling, on a fixture, or going into the wiring at all. Again, some of these benefits, you're not going to have as many components. You're not going to have your ancillary ceiling or wall sensors. You're not going to have a daylight sensor. Those are already in the fixture. So again, that also trickles down to labor savings. And as everything is going to be configured in the fixture, that's going to be a little simpler. Now that being said, having your power in the ceiling and your smart sensors and devices, that's going to be perfect set of infrastructure for any future IoT technologies that can be integrated with your lighting systems. A good way to think about LLLC, your Luminaire level lighting controls, is on the right-hand side as a one-to-many or a one-to-one relationship to fixtures. When we talk about network lighting controls, we're talking about, hey, we have a load controller that's going to be dimming up and down a group of fixtures, and it's going to listen to, be it a ceiling sensor, daylight sensor, wall control. But the real distinction in network lighting control zone-based application is that one sensor or one set of sensors, one load controller, is going to control many fixtures. A Luminaire level lighting control fixture, it will have one load controller, one sensor controlling only one fixture. So that one-to-many NLC zone-based configuration will be different than the one-to-one, one sensor to one fixture configuration. And as a bonus, if you're looking at code, the Luminaire level lighting control technology will automatically meet code. We're looking at, and this is specifically for the Washington State, and I double checked the Seattle, the upcoming Seattle 2018 energy code, and it actually is written in the same language, where if you look a little closely, and let me use this here, the spotlight. As the properties are listed for LLC, they are listed right here in the code as well. You know, to be independently configured, we want to ensure that LLC luminaires are individually addressable. They monitor occupant activity as well as ambient light, so you know your integral occupancy and daylight sensors, and the ability to configure and reconfigure. So we're talking about a networkable solution. So again, the properties of LLC are written in code where if you want to apply network lighting controls and you apply LLC technology, you are meeting code. I want to call out a functionality example just to highlight the power of LLC technology. And the beauty of this example that I'm going to show is the majority of LLC fixtures can, without being configured, just out of the box, powered on, the majority will be able to operate in this manner. Consider just an office setting where at 7 a.m. you're going to have your lights just start to come on, but we're not going to have the lights go on to full bright. Anyone coming in, you know, from maybe like not the brightest day at 7 a.m. is going to have a lot of glare, discomfort glare just walking in this room. So lights can turn on to a background level, say 20% brightness. It's going to make it very nice for the people just coming in so they can visually adapt to their new setting. Let's say, you know, around 9 a.m., a couple of people already inside of the office. So when they're in their desk in their area, the light above them can be at the brighter level. So the task illumination is very appropriate. But other spaces where people have not come in yet or walked in or are still empty, the lights will be on the background level. So it's not as glary for the people already in the office. It obviously saves energy, but more so it creates a more pleasant experience. On the inverse, when people are leaving, obviously as people leave and the areas become vacant, those lights will go back to the background level as people continue to trickle out. And ultimately, when everyone leaves, the lights can go dark. Again, very powerful functionality. Number one, for the comfort of the people in the space. Number two, it meets code, as we saw, just automatically. Number three, energy savings will be there. And you don't necessarily even have to program everything already. That's a lot of this is done by default, and any additional programming is just going to be yielding additional savings and comfort. Mentioning it again, you'll have smart devices in the ceiling and power. LLC technology can be that infrastructure, the IoT technologies of tomorrow, both inside a building, because each sensor can gather data at a very granular level and share it with the other systems in the smart building ecosystem, be it security, HVAC. And not only that, but we're starting to think beyond a building, or the building as that communication point, as it will be communicating with different power providers, utilities, demand response programs, or just distributed energy resources. So that is the future, and it's coming. And LLC provides a very granular set of smart devices that can be that infrastructure. Also, at the end of our stories, we'll be sharing a luminaire level lighting control study that NIA published earlier this month, September 3rd, and it is available as a handout. If you see on the bottom right as well, you see a handout. You'll be able to see that case study that we're going to discuss a little bit at the end as well, if you are so interested. As I had mentioned before, we were talking about the common pitfalls, and I mentioned how, hey, listen, this is more so an emerging technology as of a couple of years ago, thinking it was coming to fruition 2016, 15, 17. Now it's actually a very solid solution where the properties really address the common pitfalls that we were thinking about. You know, constructability, just making the fixtures more flexible, not needing to have ancillary controllers. Obviously, by default, if you have LLC fixtures, you have controls in a space. All you need to do is maybe add wall stations, but just having the sensors in that space will make the experience for the tenants and energy savings a lot better. Again, just less components and the ability to reconfigure without changing wires or going to the ceiling helps maintenance and ease of maintenance. The savings that you get from not having as many components and the dimming, the sensors will yield additional savings. So it's a more cost attractive opportunity as well. Obviously, the ability to be more flexible can help those design expectations or shift if the design needs to shift even after the fixture and the groupings have been done. It's very easy to go back into a tablet, phone, or remote and change the settings. And ultimately, hey, if the LLC fixtures can get to 70% of how you want to configure a space, it's a good way to help your tenants and your stakeholders, but you always will still want to have those communications, and I hope that is a common theme throughout our stories. So before we actually start, I want to take a quick moment here and ask if anyone has any questions. Again, questions on the chat at the bottom right of your webinar dashboard. You can type in any questions and I can see them at any time. We'll have a couple of other moments for questions, but please engage with us. At this time, I'm going to ask Dan Salinas, I'm going to share the presentation with him, and he's going to be walking us through design expectation and maintenance as common pitfalls. Dan, I am passing it on to you.
Thank you. And let's see if we are all, let's get started here. So welcome this morning. It's good to be able to spend some time with you all.
Hey Dan, I just wanted to call out, hey, we're looking at your the notes screen if you want to share the other screen.
Thank you very much. Let me make sure that I get the right screen on here. This is one of the issues of having to watching what we're doing here. Let me get to the final screen.
There you go. Yeah.
Okay. Still on the wrong screen?
Yes, and that's on the sharing. And if you see that little drop down, and you select the other one.
Got it. And let's take. How's that? Are we there?
I think we are golden. Yes, sir.
All right, great. Thank you very much. I appreciate that. Okay. All right. So thanks for your patience on that. We walked through this yesterday, but there's always going to be issues that you run into on these things. So, right. So when you look, and we're going to talk about some things today, but here, first, some learning objectives that I've got when we walk through this. To understand the needs of a project and why long-term maintenance should be part of the design process, ensuring there's a full understanding of an owner and user's requirements during the design process, and how design concepts not fully resolved in advance can become a long-term issue if not dealt with at a time of construction. Now, I call this a tale of three museums because I'm going to be using examples from three different museum projects. What you see on the right here is a picture of the Vatican entrance. When you look at a picture of an iconic building that has remained for many years, such as the Vatican, do you think about how the use and care of that building has led to its long duration? Probably not. But in reality, you can have a fantastic piece of architecture in a wonderful location with the most advanced equipment of the day, and still it would go to total waste unless there was someone with a plan and a tool bag to keep it going. Bellevue Art Museum. The Bellevue Arts Museum has been around for since 1975. It was founded. Now, it's dated back to the 1940s, and it's tied to the Bellevue Arts and Crafts Fair that was begun at that time. So that's where its history came from. The museum was originally meant to be an arts and crafts based, museum heavily attended by schools, families, and lovers of the arts and crafts. In 1982, they moved into the third floor of Bellevue Square, giving them a better visibility and accessibility to the public, as well as a great diversion from shopping. The museum thrived in that location for many years, but it got to be so big they needed to expand. So in around 2001, they opened up a new museum right across the street from Bellevue Square, in a building that was designed by the architect Stephen Hall. Great building, great bones to it. The facility looked great, but things changed. There was less arts and crafts based exhibits, more permanent or long-term, long-duration traveling exhibits, more contemporary and modern art with celebration of the building's architecture, both interior and exterior, as a main focus. Among the lighting challenges, the most noticeable was the use of monopoint track fixtures, which were not as flexible as using standard track lighting, making it more difficult to light the pieces. And you'll see on the image on the left, one of the previous galleries there that had those monopoints. And you'll see on the right where after the renovations happened, they added track in different areas. They're two different rooms, but the same principle happened in both. Where they added track lighting that made it more flexible for the art and the spaces to be used for different types of exhibits. So they had a great designer, both architect and lighting designer, but the architect did not want track lighting to mar his ceiling. So the main hall, with its varying staircase, was designed for openness with minimal opportunity for exhibit lighting. And in fact, on that picture on the right, there originally was no lighting on that ceiling to light artwork. It was primarily depending on those two large skylights to fill the job. In addition, there was limited availability of receptacles in most areas, so even portable lighting was unwelcome. So an interesting side to this is if you've ever been to the Guggenheim, and the first time I ever went to the Guggenheim in New York, I noticed that there was wire mold used to put in exit signs because there was no close by power sources that they could use. So they had to use wire mold to come in from distant sources across those beautiful walls of the Guggenheim because there was no pre-planning for something like that. In 2003, the museum, the Seattle or the Bellevue Art Museum, closed its doors as they tried to figure out what happened. It was due to lack of visitors and their change of vision from being arts and crafts based. Income was down, donors were down, and visitors were down. So they put out a search for a new director. Fortunately, during this time, they had a very good facilities manager who was also a big fan of the arts, especially museums. We worked together to ensure the museum's lighting control system kept things off when they were not needed to reduce energy use and set various show schedules that were quickly loaded for special events. Something easy for him to understand and quickly do instead of navigating software scheduling, which can become cumbersome and confusing to someone who has a whole lot of other things to worry about. And when they were able to renovate the museum, even though much of the lighting was changed, the control system was easily modified for the new equipment without much additional cost and no need for additional training. So the museum went through a massive redesign of the lighting and some of the interior architecture. And in 2005, with a new director at the helm, whose background was in arts and crafts, they raised money to move the museum back to an arts and crafts base. Exhibits became more interactive to teach the public more about art. Schools, families, and donors returned to what made them successful in the first place. See the Taste Cafe at Seattle Art Museum. The Seattle Art Museum opened their large expansion along First Avenue in 2007, and where they took the original Venturi portion of the museum, and they expanded upon it to the north and took up the entire rest of the block with this renovation. And with that, they put in a restaurant on the main floor along First Avenue. The restaurant, a few years later, decided they wanted something a little less cafeteria look and more something that gave them a little more of a bistro feel. So they remodeled the restaurant and repurposing the use of that restaurant. So new wall treatments, lighting, and furnishings. The whole look was of connecting the museum attitude with the rush of the First Avenue outside and finding yourself at a table with delicious lunch and good friends. When reviewing the issues of the first installation with the customer, the biggest complaint was the original clear cased glass incandescent Italian pendants. Because of that, of the nature of clear cased glass, if you don't do it in with really, if you really don't do it well, it always looks dirty. The clear over clear. Over the years, they had ordered new glass that took months to get and still had the same issue. Eventually, the manufacturer stopped making the glass. So it was one of the first things we had to tackle. Now, cased glass is a process of blowing first an external glass form, for this purpose, an 18-inch long by 5-inch diameter closed-in cylinder. Next, an internal glass cylinder is blown inside the first, and the two are fused together at the open end. Normally, you will see it with colored glass as the interior and clear glass as the exterior to give more depth to a piece of glass, and it looks really nice to see that colored glass depth. But when you do it with clear glass on the inside and clear glass on the outside, due to some of the natural properties, if there's any imperfections on the glass, that those become very noticeable, and allows you to see those imperfections in between that glass that you would not see under a colored glass interior. So they really had to do something about this because the glass always looked dirty. So we went through several different options on how to replace the fixtures, what to do with them. They liked the concept of the fixtures. They didn't want to really be tearing up the ceiling to put in new fixtures anywhere else. They wanted to really kind of keep that concept but make a change. And so the team, after a lot of discussion and looking at different concepts, the team decided to replace that glass with locally hand-blown art glass using artisan glass blowers from the Puget Sound, 2 of which were from the Pilchuck Glass Studios. No changes were necessary to the control system or ceiling because we kept the same layout and the control technology in place and adapted it to the new conditions and equipment. I'll have to say that one of the best benefits of working on this project was when we had our design team meetings every 2 weeks. We met at the restaurant, which was in full operation at the time, and we were the guinea pigs for the chef as he came up with new creations that he wanted to use. So while we were having our meeting, he would be loading up the table with some of his new creations and some wonderful coffee. So it was a nice perk on a project like that. So, and the third project I want to talk about is the Makah Cultural and Research Center in Neah Bay, Washington. If you've ever been to this museum, it's quite a drive, quite a ways to get out there, but it's a unique piece of Northwest history. The Makah Cultural Research Center was constructed in 1978 with the purpose of exhibiting an important part of Northwest history, the artifacts of the Ozette Village archaeological site. The Ozette Village was buried in a landslide over 500 years ago, but in the winter of 1969, a storm exposed part of that village. Over 55,000 artifacts were discovered and preserved for historical research and cultural understanding. Each type had its own unique preservation method, whether it was fabric, woven wood, bone, or just wood. Those made of wood were at risk. Those made of wood which were at risk were preserved in a special mixture of paraffin injected into the wood to keep it from degrading. The museum only displays a small part, less than 10% of what was found. The rest are in an adjoining temperature-controlled building where each item is cataloged. The macaw are deeply rooted in their culture, so you'll find no casinos, no gaming facilities, and no alcohol on tribal land. They hold to their fishing industry and their cultural heritage, which is really strong when you're working with a client like this, that what you do and the artifacts that you're lighting, that's their culture. That's an important part of who they are even today. So it had to be very cautious on what we did. The Macaw Cultural Research Center researches artifacts, language, cultural heritage of the Macaw people, and this museum is a critical part of that to the tribe. Many schools and universities send buses of students to visit the museum with its glass cases of treasured artifacts and dioramas that give a glimpse of how the people of the Ozette lived. When someone heard I was working on this project, more than likely the next phrase you'd hear out of their mouth was, "I love that place. We went there when I was in school, and I've taken my family there." That's not an easy place to get to, but more than worth the drive. Needless to say, the illumination of this type of work is important, as well as how the facility maintains these precious pieces of history. Prior to 2017, when we renovated the lighting, the lighting in the cases was via incandescent track lighting on dimmers that were located inside the cases, and then lamps on the rest of the gallery spaces were on larger wall box dimmers in an electrical closet. The lamps were various arrays of par lamps and reflector lamps of varying wattages, whatever was available in town. Each display case had its own dimmer, and the open areas controlled with a large wattage incandescent dimmers overridden by circuit breakers. No time clocks, just circuit breakers. The display cases were engineered with internal fan coil units underneath of each one of the display cases to bring in filtered fresh air, which was exhausted out the top of the cases into the high open ceiling. Each case had its own thermostat to control the case temperature and the fan coil speed. It sounds workable, right? Unfortunately, the fan coil units never worked well, and maintenance became a really huge issue. This meant that the artifacts were being subjected to more heat than allowed and required continuous monitoring by the curators and museum staff under the oversight of a conservator who set the maximum illumination at the artifacts to maintain maximum lumen hours on those artifacts. Because the fan coil units no longer worked and the cases were never designed to be turned off, once again, because of those fan coil units, the lights stayed on 24/7 for years. The conservator had to reduce the light levels on the artifacts to extremely low levels, which made that incandescent light even warmer, to a point where details of the artifacts were hard to see. And in some cases, lamps were too close to some objects, and the paraffin treatment began to dry out from the heat of the lamps. Nia Bay is 54 miles from the closest city, Port Angeles. But that 54 miles of winding road is an almost 2-hour journey. And if a technician was not available and another had to come from Seattle, that is now 4 hours each way. Very expensive to keep specialized equipment running. And so in 2017, we renovated that lighting system, replacing worn out track and incandescent heads with new track and LED technology track heads based on light engine technologies, not on replaceable lamps. We also installed a new architectural control system along with occupancy sensors. The conservator was brought in, and we discussed effective light color, light output, wattage, maximum lumen hours allowed on the artifacts, and if we could increase the light level, because the new control system now allowed each case to be controlled by external occupancy sensors that illuminated the space as you entered the gallery, turning it off behind you when you left, which allows us to increase the amount of annual allowed light on the artifacts while staying well under the conservator's requirements. You'll see in the middle, you'll see the old system with those incandescent R lamps on track, and how many of those fixtures there were in each one of those to try to light the different objects within the space. And you'll see on the far right what it previously one of the internal cases looked like. Now that photo had a little extra exposure on it, so you actually see more of it than you would in reality. In reality, it was very dim and very yellow. On the far, that's on the far left. On the far right, you'll see one of the curators working on the newly illuminated system, where you now see the objects stand out. The light level, we were able to increase the light level in those, and the color of the light makes everything pop. And we had a couple of people that were commenting that there were details in the objects that they had never seen before that now they could see very clearly. Within there, some fine, intricate work. So being able to light it well, proper color, but also to remove that excess heat that was going on inside of those cases, and the fact that we now have control of the outside of those cases from outside with occupancy sensors, similar to what you see in a grocery store where you walk up and the cases light up on you. It's a similar situation here, except for we brought the gallery lighting would slowly fade up, and then the display cases would emerge from that as they started to rise up. So now the details are visible on even the smallest artifacts, and the galleries open themselves like a prize when you enter, instead of looking like a dark yellowed cavern. The fan coil units were totally disconnected, no longer required, even if they did work. The fully light engine LED track heads mean no more installing the only lamps you could find at Home Depot, because the one you should be using are an 8-hour round trip away and only last a couple of thousand hours. And now the system goes dark at night, waiting for tomorrow and another group of visitors to amaze. So final thoughts: whether you design or install or maintain a system, when you understand that what you do now may have long-term benefits to the life of that building, or it could be the cause of incredible cost implications later on, make sure to pay attention to the details now, as those details more than likely affect the people using that system every day. It has been my experience that when I take a little extra time to understand who uses that system I designed, how they use it, and what their abilities are to know how to use it right, the system becomes more effective, efficient, and reusable as their needs change going forward. Thank you. And now I'm going to turn it over to Shawn, who is our next presenter.
Hey Dan, do you mind right before? And I apologize, Shawn.
Nope.
Before you go ahead, do you mind if you address a question someone left
sure
you
can.
here?
Yes.
Awesome. Thank you so much. Couple of questions, and I'll ask them this way. One is, can you talk about, hey, what are the implications of throwing more light on retrofit lighting projects, both for area lighting and indoor lighting, especially for large gated communities in existence since decades? Like, what are the implications of just throwing more lights, interior and area lighting?
Now, you have to be very careful when you're talking about the idea of just throwing more light at something and not addressing the actual architecture itself first. You want to be able to look at it from the standpoint of saying, okay, I want to understand what the purpose of this was. If you're doing it because you feel that originally it was done on a super tight budget, so they didn't put much light in except for to get from point A to point B, but there's a lot of landscape in between point A and point B that could be highlighted. Think about it from the standpoint of, can that landscape lighting that you're adding be part of not only the decor of the space, but also part of the wayfinding aspect to get from point A to point B? So that what you're essentially doing is you're resupporting it. If you've changed the main pathway lights to something that is more efficient and lower in wattage and is more controlled, so that you're not doing any illumination of what should be a dark sky. You're instead keeping everything below 90 degrees and down into the surfaces where you need to be. Then you're in a situation where you can add those dressings, add a little highlighting to the landscaping to assist with it, because we see vertically first before we see horizontally. So you want to be able to light up some of those objects softly, not overly bright, but enough to add to the feel of it. Be very careful when you add lighting. It should be considered like seasoning. You take care of first what the initial needs are, the meat and potatoes, and then you start doing little bits of seasoning here and there, being very cautious that you're not overdoing it. Too much salt is horrible. So, you want to add just a little bit of that here and there and seasoning to it and make it dress out. So you can do it, but not throwing a bunch of stuff at it. You want to be able to be careful of the architecture and what you're trying to light.
Thank you very much, Dan. And there's another question, but we're gonna take it offline. Ramohan, he was asking about single tube retrofit purpose reflectors, but it's a technical question, so I'm gonna say we're gonna address it offline if we can.
Yep.
Yes. So
Okay.
yeah, let's continue with Shawn on. Yes.
Okay.
Dan, thank you very much. Armando, let's see what we've got going on here. Let me just, all right. I think that Armando, can you confirm that my audience view is correct? You're seeing my screen here?
Seeing everything as it should be, good to go.
Outstanding, fantastic. All right, once again, Dan, thank you very much for that. Armando, also thank you for inviting me to participate in the panel here. I've been asked to speak a little bit about controls and stakeholder engagement. So as part of that, Dan had mentioned this, and Armando as well, that all of these issues that we're talking about kind of relate to one another. They really start to intertwine in a lot of different ways. And I'll show you a couple of examples of some of those things, but I want to start with the idea that the name of this class is What Went Wrong, when the reality is there are relatively few projects that are truly failures. There are lots and lots of projects, in fact, almost all, that could somehow be made better, either with refinement or with a better understanding of the project needs or controls or engagement, all these things. So I'll try to give you a little bit of background into a few key projects that you may be able to derive some thoughts or some benefits from with respect to those things. So to begin that, let me get my mouse together properly. There we go. All right, there we go. All right, so the first part of this with respect to controls is that we all know that networked or general advanced lighting controls are really, really useful on projects. Lots of different reasons for them. They add flexibility, they make the spaces work better, they add to user satisfaction, all these things. They save energy. Armando spent a pretty good amount of time talking about some of the benefits of LLLC. I'll show you an example of that a little bit further along. But we all have stories about how end users in particular either didn't understand how a network lighting control was supposed to work or didn't understand why something was happening. How come the lights are dimming at the perimeter of an office? In fact, any of you who have been in any of my controls classes over the last 30 years will understand what this image means. It's a Dixie Cup, of course, and if you don't know what that means, well, I have an upcoming controls class very shortly, November 3rd and 4th. So please come and take that. Essentially, the idea is that the best lighting controls system can be defeated by a simple Dixie Cup over a sensor. And I will tell you exactly how I know that from a project that I did in 1993, I think it was. So we'll talk about that, but we'll talk about that, why that was an issue a little bit later. Let's make this really practical. So let's talk a little bit about Pacific Place. I'm assuming that most people, at least most of you that are in Seattle, have probably at one time or another been to Pacific Place. This is the retail mall downtown. We started designing it in, I'm going to say 95 or so, and it opened in December 1998 to a great deal of fanfare. Recently, Gensler has actually done a significant amount of renovation. So the mall kind of went about 20 years before renovation had to happen, and that's a pretty good run, I think. Design. NBBJ, I have Coder Kim there, and that's wrong. Apologies. Elkis Manfredi was the design architect. Lighting, we did when I was with J. Miller & Associates, and the electrical engineer was Bullion, an outgrowth of Bullion Christopherson Shire. Some of you may know that name from there. So let's talk a little bit about this. This was a pretty successful project for its time, right? In fact, in some ways, it was so successful that I had to go to a specific meeting with DPD Energy Code officials to discuss it, because they literally didn't believe that we were using so little energy in the mall, primarily because we were using a relatively new lighting technology at the time, which is ceramic metal halide, when they were used to seeing predominantly incandescent kind of lighting in spaces like this. So a key part of this, to kind of bring this in with respect to controls, is that we had spent a lot of time actually developing the lighting controls. Those of you who know me will know that this is a particular passion of mine. I like to be able to refine the lighting, and I also like to make sure that the lighting responds to things like daylight and external stimulus. So we had daylight threshold switching, we had neon dimming, compact fluorescent, linear fluorescent dimming, and we had pretty closely defined zoned area switching in this space. In fact, if you look in this, this is of course the atrium space in there. And during the daytime, there's a tremendous amount of light flooding in. This was originally intended to essentially mimic some of the gallery spaces or arcade spaces that you might find in Europe. Italy or Brussels, places like that, where we have an enclosed retail area that has still some connection to the outdoors. So lighting controls was a fairly important element for this. Now, one of the interesting things, we designed this to have its own separate standalone lighting control system. Of course, during the construction process, lots of things can change. The lighting control system as a separate element got value engineered out of the project. So essentially, lighting controls then fell into the lap of the HVAC system. I think it was Siemens, but I'm not 100% sure. It was a long time ago. But what wound up happening at that point was that then, instead of having a very specific person or body in charge of programming and maintaining the lighting controls, what wound up happening is that that kind of became a bit of a hot potato, right? Who was going to be responsible for programming? Who was going to be responsible for maintaining? Who was going to be responsible for making it all work? So we had put together a pretty involved sequence of operations, how this was supposed to work. And of course, we'd zoned everything on the plans and all of these things. But what ultimately wound up happening was that there were lots of problems with not only the initial installation, but once we finally got everything programmed correctly, every single time there was an update to the HVAC system program, it would screw up the lighting program so that things were not working properly. Personally, the thing that vexed me the most, let's see, where is my spotlight? There it is. Under the escalators here, we had a series of tight beam downlight spotlights that would shine through this louvering material and highlight the escalators. It was actually quite lovely when it worked. And instead, what would frequently happen was these compact fluorescent tubs, which were just supposed to be emergency lighting, and in fact, they were supposed to be linear fluorescent on the side. These tubs weren't even supposed to happen. This is another thing that kind of went wrong. This was another VE. They decided that it would be better to have compact fluorescent tubs as emergency lights. So most of the time, the emergency light was on instead of the actual light that was supposed to be there to light the the treads. Now, this doesn't seem like a big deal unless you're actually on the escalator and you're looking straight ahead. And every time you come into the field of view of one of these things, you get a bright flash in your eyes, none of which was supposed to be there. So a very similar kind of thing with respect to this was the parapet lighting. So we have neon in this parapet up here. You can see kind of the blue. And we also have a variety of ceramic metal halide accent lights shooting across the trusswork. The idea here is that this emulates some lighting that's over here that catches from uplights from below. And this, of course, is meant to keep that whole trusswork from appearing dark and ponderous at night. If you go in there and you see this, when this is completely black instead of having light shooting across the trusswork, it's really unfortunate. You really get a very kind of ominous feel. You've got the kind of trusswork of Damocles above your head. So the problem was, this is its own dimming zone, the neon. We basically designed it so that the actual output of the neon that we wanted was going to be about half of the full output, which was very difficult to get that, again, programming bit to stick. And the daylight threshold controls for lighting across the truss, they basically kept essentially mucking that up in such a way that the lights would be burning all the time. Now, ceramic metal halide lamps had a lot more lifespan than incandescent, but nothing like the 15,000 hours that we'd really want to have, or the 50,000 we'd have with LED today. So this is an example of a programming issue, and it's also an issue of making sure that you have the right people thinking about things. Now, this is, I don't want to, how to say this. This is a different example. This is a contemporary mall that we designed down in Waikiki. This is the Ala Moana Mall. Similar time, similar light sources, similar design concepts with respect to daylight and programming and all those things. In this particular case, we had a dedicated lighting control system. We had people that were specifically responsible for it. So take that for what it's written. All right, let's switch gears for just a moment here. Another project, 525 Golden Gate. This is the San Francisco Public Utilities headquarters. We began the design for it in 2006 and it opened in 2012. KMD Architects, again, J. Miller and Associates, but then, sorry, not J. Miller and Associates. This was when we were with Pivotal Lighting. So it was an AIA Coat Top 10 project, and it was designed to be among the most energy effective urban buildings in the country. From a control standpoint, we essentially used every single one of these control strategies someplace in the building. This is a very controls intensive space. It was also extremely forward-looking with respect to daylighting, with respect to controls, user interfaces, all of these kinds of things. So we had originally designed the space using this exterior louvering system, multi-story louver system. You'll see that we've got a daylight model of it right here. We tested it in a lot of different ways. And we had originally talked about looking at using an articulated ceiling system. This is very similar to something that I did successfully in a project in China. But what was very interesting about this is when we had our stakeholder meetings, so we spent a lot of time talking to the end users, talking to the owners on this particular project. Everybody liked this idea, this concept, but we wanted to try to have some kind of lighting control system that would give the occupants more direct control over this light at their individual spaces. We retained the exterior louvering system. So one of the things we looked at was the idea of what we call LLC, or at the time we used to call them vertically integrated luminaire systems. In particular, we were looking at a system that had come out in 2000 by Lidolite. It's called Ergolite, and at the time it was also being shared with gen light companies. So we had the ability to potentially go ahead and have a fixture over everybody's desks and give them the ability to control their lighting directly from their desktop. Anybody who'd been to the old lighting design lab up on Capitol Hill, this in fact was the very fixture that I had over my desk there when we were there years ago. We were looking at this particular system for 2 projects, this one and also for Manitoba Hydro headquarters up in Winnipeg. We didn't really use it in either case. Why? Because at the time, Luminaire level lighting controls or vertically integrated Luminaire systems would have required us to use multiple lighting control systems. We would have had to have one control system for the office lighting and a completely separate lighting control system for all of the rest of the lighting in the building, the down lights, the accent lights, all these other things. The great news here is that when we're looking at systems today, LLCs are actually part of a subset of networked lighting control systems. So we can use them for places like open offices, spaces like this now, and still have the same unified lighting control system for the rest of the project. So there's one set of interfaces, one set of gear, one set of buttons to push for the entire place. This, of course, is what we ultimately wound up doing, which is we have linear fluorescent systems here. Each individual ballast, so 2 lamp pairs, is individually addressable. These are digital devices. So we have the ability to modulate light in a very fine way. We don't have the sensors that we would have with an LLC system, although the astute observer might notice that if we zoomed in close here, we would see that this is the first project that I'd ever done with wireless networked lighting control system sensors, both occupancy sensors and daylight sensors. So if anybody is still sort of concerned about wireless sensors, this is a great example that actually works quite well. Now, all of this kind of came about largely through stakeholder engagement. We had meetings, we had discussions, we tried to make sure that everybody had a voice at the table, right? Now, this is one really interesting part of this. This is one of the key lobbies. Now, you'll see that we have this big video screen. We engaged in dashboarding on this project for energy use, not just for lighting, but all the other systems. So at various times, information about what energy is used on each floor will show up on the screens here. And this was something that they really wanted. Now, one of the really interesting things about this project from my perspective is that we have the ability in this particular space to do color changing lighting from downlights. We also have, of course, over here, we see that we had lighting above that was meant to show off the mechanical systems. The intent had been that there would be very little glow up in the ceiling here, and that the colored lights would give us the ability to modulate mood during the daytime. We'd have some light. Everything that you see here is LED, and all of the lights that are here. It turned out that the CEO took one look at this with the lights above the ceiling plane full bright and said, "That's what I want. I love seeing all that stuff." So it's really important to kind of understand what it is visually that your clients, your folks are going to be looking for. So all of this kind of comes back to this whole idea that somebody needs to really put together a sequence of operations. This is incredibly important for projects. Now, there are a variety of different things that somebody has to answer, right? What are the time schedules? What are the light levels? What are the dimming thresholds? You can put all this information into a lot of different ways, matrices, narratives, various systems, including things that look an awful lot like this. You might have a narrative that tells you what is happening. This is the narrative for the typical private office in that 525 Golden Gate project, right? Tells you everything you need to know to program the system. Or you might put it into a matrix like this that winds up having more information that sits on a set of plans rather than a spec book, right? So the last kind of project to kind of tie all these things together a little bit, again, local to Seattle, is the Amgen Helix campus. You guys might know this better as now it's going to be the Expedia campus. Coder Kim Architects, NBBJ, FLAT, AEI. I was with NBBJ when we designed this. So this was originally meant to be about a 1.3, 1.4 million square foot biotech campus. We ultimately didn't do all the buildings because Immunex, which was a local company, was purchased by Amgen, and they decided they didn't need quite all the buildings. So this kind of became the campus here. Designed in 1999 is when we really started, and it was fully complete in 2005. Now, one of the most important things about this particular project is, from my perspective, it was still mostly fluorescent, but almost all of the fluorescent lamps on this project were designed to be dimmed and dimmable, right? And part of that had to do with the fact that we spent a lot of time doing meetings with end user groups. So these are a couple of pages from one of the end user groups that meetings that we had. You'll notice talking about visual systems, lighting terminology metrics, trying to bring people along, lighting controls. We spent a lot of time talking with them about things like this. Here are a couple of other things. All fluorescent luminaires, high output lamps with dimming ballasts, right? So we had dimming ballasts all over the place. Now, ultimately, we didn't wind up getting this fully the way we expected. There were a handful of places where we had switching ballasts rather than dimming ballasts, but for the most part, in the offices, in the labs, in some of the corridors, most of the spaces were allowed to have dimming systems. And this goes back to, the early 2000s with fluorescence. So it was not inexpensive because the end users understood how important that was for them. And in fact, they also allowed us to do some really interesting things at that time. We used this brand new, what was then an experimental lighting system with LED lamps. So this pedestrian bridge was designed in 1999. These are LED strips that are lighting this pedestrian bridge. This column is lighted with an internal LED system. So the reason, again, that we were allowed to push the envelope and to go ahead and do these things was that we had that kind of engagement. So they allowed us to do things like having lighting systems that had very wide spacings so that they would match the expressed architectural modules. They would also allow us to have daylight responsive systems in there. Same thing in the labs. We had a relatively new kind of lighting system within the labs where we were using indirect lighting. This has become standard for a lot of labs now. Where we had a much lower measured light level at the lab surfaces because we had higher perceived brightness from the indirect system than we would with the direct system. We proved both of these things out actually at the old lighting design lab up on Capitol Hill when we did mock-ups for both. So a big part of stakeholder engagement for you guys may in fact be things like mock-ups. Show people what's going to happen. We did similar kinds of things for all of the public areas. You'll see lots of different lighting styles here, and all of it, or almost all of it, is controlled by dimming control systems so that we could modulate the amount of energy and the amount of lights we were using. We also, on this particular project, had a very early demand response system. I don't know that it ever got used, but they had the ability to diminish the lighting load by 25%. So another part of this stakeholder engagement is the idea that you really need to address the occupants post-construction. One of the most important things I think of is commissioning occupants, right? Making sure that occupants understand and know why lighting control systems are doing what they're doing. That's going to lead to things like a diminution in callbacks for people wondering why the lights at the perimeter of the building are dimming or turning themselves off when there's abundant daylight, right? So dashboard it for them if you possibly can. And this particular project has a really interesting sort of take on it as well, that we had continued stakeholder engagement. In 2012, we actually engaged in a hardware upgrade for the lighting controls for Amgen Helix campus. This was largely based on the fact that a lot of the circuit boards that were in the original system were no longer being manufactured. So we went ahead and we did mock-ups again, surveys and user group meetings, all of those things to lead to a successful project so that we would have fewer of those questions about what went wrong, right? Because things change. So that is my story. I'm going to stick with it. And now I am going to hand back to Armando and make Armando the presenter, and will be available if there are any questions. So let me see.
Shawn, thank you very much. We do have a question if we can ask for your general thoughts. Bear with me one moment. And let me know when you pass on the presenter baton.
I'm trying to find where that went to. There it is.
Beautiful.
You are now the presenter. You have the power.
All right.
Hey, Armando, if I could make a quick comment about something Shawn said,
Please.
I think it was really important.
Please.
It's post-occupant evaluation, not occupancy. I like when you said that term. You're evaluating the occupant in the space, what they know about their lighting control system. That's a fantastic idea, because I've seen it where we've had in years past, we had a 2-channel sensor in a small office that had 2 fixtures along a perimeter window wall, and people would not understand, and they'd have both lights on in the afternoon. And so then I talked to the facilities manager, who wrote up a memo, sent it around to all the offices that says, here's what's going on. If you don't need that other light, it will go off and you don't have to worry about it. So we came back a couple of weeks after that, and I couldn't find a single office that had both lights on. And in some cases, no lighting, because they started realizing that they had enough light in the space as it is. There was no reason to have those on. So once they had that little bit of knowledge, it worked fantastic.
I was kicking myself a little bit because we had actually put together 3 or 4 different 2-page documents to hand out, basically for Immunex and Amgen to hand out to their employees, and we suggested it be part of their onboarding process, right? That this is what to expect. This is how the lighting control system is going to work. Because, for example, in the labs, most people at the time weren't used to daylight responsive controls in labs. So, you know, that they had been very much excluded from being part of that kind of system. So I was kicking myself because I'm such a digital pack rat and I couldn't find those sheets.
Yeah.
Love it.
So Armando, what was the question?
Sure. So general thoughts, and either of you, if you can answer. So someone's asking about just wall washing applications. General question on, hey, what type of fixture would be good? What type of control and what application would be good for wall washing applications, basically?
Okay, so there are kind of 2 ways to think about what commonly is thought of as wall washing. One is actually wall washing, one is wall grazing.
Mm-hmm.
So you can either light a wall, in which case it highlights that thing, or you can graze the wall, in which case you can see that it is really emphasizing texture. So sometimes you really want to emphasize that texture, sometimes you don't. For example, if you're lighting a gyp wall, you probably don't want to graze it, because if you do, you're going to show every little imperfection unless you have a level 5 finish. Right. Even then, it's still a little dicey. Yeah. I mean, unless you've got a real Venetian plaster guy, it's going to be a little dicey. Personally, I like to wash walls with linear light sources. One of my favorite walls that we ever washed was if you get down to SeaTac Airport in the ticketing concourse, that big wood wall, that mile-long wood wall.
Wow. Yeah.
We actually installed the wood wall as part of the lighting retrofit. We paid for that out of a lighting budget so we'd have something to wash. Something to tie the whole space together. So I do think that lighting controls are important because you really are going to want to modulate that. As Dan had mentioned earlier, we derive almost all of our perception of brightness in any given space from the vertical surfaces that are around us, right? Secondarily, ceiling and floor and all that stuff, but primarily it's the stuff right in your medial vision.
Correct.
So, Dan, what do you think?
No, I agree with you. The object of using linear, if you're going to wash a wall, you have to really determine what you're going to use that space for. I've seen people light every wall in a room with washing, and I'm going, no, that's just overkill. That becomes sterile. So you want to use it, kind of like I was mentioning earlier about using seasoning. Same with that.
Seasoning.
The nice thing about wall washing is that once you illuminate some of that vertical, it means that you don't have to be putting in so much overhead lighting of the rest of the space. You can minimize it somewhat because that vertical illumination, the perceived brightness of the space changes. So now you can find yourself actually doing more with less when you're doing that. And it can, but you have to be cautious of it, that you're using it right. I've done it before where I'm washing one wall, but on other walls, I'm just highlighting pieces of artwork just to let them be emphasized. But Shawn is right. If you're going to wash a wall, and you can't graze a gyp wall. You could wash it by a little further distance out, but you can't graze it. Grazing is nice for things with texture such as brick, wood, different kinds of qualities of plaster where they've got maybe some thickness and texture to them that you want to really emphasize. The nice thing about dimming systems is that can introduce drama to that wall at different points in time. So that in evening you can bring it down and create drama with a wall that's grazed, that you can bring out a little more emphasis of it, whereas during the day you brighten it up a little bit for just general illumination of the space.
One thing I want to amplify one thing Dan said, which is really, really important, which is that you don't want to do it everywhere.
Right.
So, one of the things, or one of the mistakes, particularly that newer designers make, is trying to accent everything.
Yeah.
So it's kind of a truism that if you accent everything, you've accented nothing. If you don't believe that,
Correct.
go to a mall shoe store sometime and look at the 47 R lamps that they have aimed at the shoes, and you'll notice that they've got a ton of quote accent lights, but it's all the same light level, so nothing is accent.
Yeah.
It's the same way. You really there for a long time there was a real push for uniformity in lighting in the lighting industry, and that's really, you don't want uniformity. You want to have some natural variability, because that's what we expect as humans.
Yeah, good lighting designers love the dark as much as the light.
I like that. Love the dark as much as the light. Again, just appreciate the wealth of knowledge on the webcams around me. We can be here all day, I'm sure. And to do that, I'll try to make these stories shorter than they could be. But I want to talk about a sunny day in New York University's 19 University Place. I worked for a trade ally called Pearl Street LEDs. We were a channel partner for companies, Philips, now Signify, Lutron, Green Creative, Luminaire, some of the most, or the products that I worked with the most. And so NYU, we're working with their energy managers, and 19 University Place is a humanities building. I think it's one of the languages offices. And for some reason, the facility management and energy managers were looking to make this specific building a pilot bed for smart lighting. And that was the word. This is 2017, and smart lighting was the buzzword. And they're looking at staff offices, just a good amount of private offices and a couple of smaller classrooms, but all classrooms were using the recessed 1x4 and some 1x8s, but they were just a couple 1x4s together. Your 2-lamp fluorescent T8 32-watt tubes, almost 5,000 kilowatt hours being used in the space. So obviously, like a relatively small sample size. They were looking to do a pilot, and they were looking to do a smart pilot, but they wanted to pick one of two solutions for one floor. noting that eventually, and this is just the way that they had set up this pilot where, hey, this one floor, we want to just do one solution and evaluate it and maybe remove and replace with the other, or to pick another floor. But hey, depending on the budget and the logistics, we were looking at two potential solutions for the floor at this 19 University Place. One solution was using Signify's retrofit kit, the Evo kit, where this had a LLC option. I'm gonna call it. It was the, I believe it's called their EC Sense technology, when their 1x4 fixtures can have the option of that integral sensor and responds natively to a wall station, and you can have a phone interface to configure that fixture, therefore dubbing it your LLC application. The other solution were from Luminaire Lighting. They had a smart TLED platform where the TLED itself, your smart T8, would have both a Wi-Fi and a Bluetooth sensors inside the luminaire itself, and it could respond to elements outside of the fixture. Although it would not be a true LLC application, as you would still need, as you see there, you would have still needed a ceiling sensor. And we were not looking at daylight options for that solution. So retrofit kit or a TLED option, they were both considered smart lighting because the fixtures themselves are going to be responding to controls. Let me bear with me, my mouse is going a little wild here. Obviously, looking at some of the performance standards, hey, like sure, the upfront costs for the TLED smart TLED solution were definitely going to be less than a retrofit kit that had more of a robust LLC technology built in. But on the flip side, the savings and the available rebates in the city of New York were definitely already benefiting that retrofit LLC application. And we had to do a solid amount of financial models for both solutions in order for NYU to decide which solution they were going to implement. And our financial models included, HVAC calculations as part of, the heat being produced or not produced. We wanted to include hardware and labor savings from, hey, you're not going to have your fluorescent lamps here anymore, so you're not gonna have to keep replacing ballast lamps. You're not gonna have to send your techs out to find the lamp to replace it. So yeah, we were calculating a lot on these savings. And unfortunately, everything that the energy managers wanted to look at was what we call the simple payback. If you install this pilot, how quickly will it pay for itself? And that's the metric that's really important for that department. And when I was working in that capacity, that was my mindset. I saw myself as that trade ally, wanting to sell as many TLEDs as possible to get the $2 to $4 rebates and do a job very quickly, move on to the next, resolve a lot of maintenance issues, just saying, hey, we're just providing good customer service. But it wasn't really until much later seeing we're not actually delivering good value to our customers, just pushing all these quick and easy TLED projects. A lot of, we were talking about how all these issues intertwine. Post-occupancy maintenance, control issues, the light quality is definitely not good. It wasn't, until much later when even starting working at the lab, when you're thinking, hey, we're not thinking how quickly is this quick retrofit or highly going to pay for itself. If we're going to implement lighting in a space and lighting and controls in a space, that building is probably not going anywhere for a very long time, and the lighting systems being much more effective and efficient these days last for 10, 20 plus years. So again, just highlighting the emphasis when it comes to cost on ensuring we tell the whole story from beginning to end and not just focus on how quickly we can pay a project. But again, back to our NYU story. Long story short, bear with me. The story ended up with Luminaire was going to provide us with the lamps. It was going to be a very economical project, and NYU was very happy with, oh, they're going to provide the hardware for the lamps, the sensors, the wall switches. We would have to pay for a much more expensive Signify EvoKit solution out of pocket for the pilot. So you know what? Let's just go with the smart TLED solution. And right before that purchase order was going to be written and sent to get the labor or other components for the platform, we learn each T8 is going to need its own IP address on the client's network. That was something that we had heard about. Oh yeah, the lamps are going to communicate in the cloud, and we're just thinking that's a third party. We don't have to worry much about this. No, we were going to require each lamp to have an IP address on the client network. And that was, not a thought where we had included the IT department on this process, on this project before. And when you think that's the what went wrong moment, oh my God, we didn't think of the implications of this. We don't know if then it could be done. And when we talk about constructability, and when you step back and you have construction project manager hat, you want to think about how efficient it could be to implement something in the project. So then when you think about then, oh wow, we're gonna have to have an IP address for each lamp. We're gonna really rely on your client's IT infrastructure. And at that point, the IT department, beyond telling us, it's not gonna happen from us. The reasons why we're like, hey, we would need to do a lot more studies, and it would be a very, very expensive lift to understand what the bandwidth is, how much do the lamps communicate, what is the expectation, and other IT solutions, be it VLANing or a different server. They would just blow the cost and the constructability or infrastructure costs out of the water for this pilot. And again, we just hadn't thought about the implications. I know there's a lot of systems that can also host their smart platforms on the cloud, and they would handle that on the manufacturer end. So that's what we were thinking, and we just never had that conversation. But when we saw what would it take to make it happen, it was just not going to be attractive. And also, there were a lot of cybersecurity concerns in the sense that specific Luminaire platform was in the DLC qualified products list, but 2.0 that had not necessarily yet looked at any of that UL 2900 standards or the other standards where they're concerned with cybersecurity. So I call it, the conclusion is that they begrudgingly piloted what we called that better retrofit kit LLC solution 6 months later, just because they had to reset a couple of the logistics that they had planned for the Luminaire already. And it was a more expensive pilot, but ultimately we were glad it went that way, and we had to wait 6 more months because we believe that they had the better solution at the end of the day. Similar project where I'm talking more so, or I'm focusing on constructability and cost. It was a sunny day in New York, and I'm gonna call it an overcast day at Dartmouth College's Berg Chemistry building. Although it seems sunny day, but New Hampshire, overcast all the times that I went there for this project. But yes, Dartmouth as a campus itself had a goal of reducing their emissions and improving their energy footprint overall by 2030. Interestingly enough, the lighting, and this is energy overall, not just lighting, but interestingly enough, and I want to call attention to this, a lot of the lighting projects only occurred when there was another larger project in a building. And for specifically the Berg Chemistry building, they were changing out, I forget specific HVAC equipment as well as chillers in some of their labs. And their project managers say, hey, we're gonna already enter this building because of these HVAC projects. If you guys wanna do your lighting project alongside, you can do it. The only reason I pay attention to that is just, even in 2017, lighting is not necessarily sometimes looked at as the, like key project in a building. It's more so like that afterthought. Hey, we're already opening the walls and ceilings. If you guys want to step into this project, and I want to ensure that I call it out because I want to ensure we change that narrative into lighting being key to the infrastructure of that smart building ecosystem. So a couple of 3 years ago may not necessarily been that prevalent, but I want to ensure that we change that conversations. So in Berg Chemistry Building, the bread and butter of the projects was the labs that had suspended fixtures, but those weren't necessarily an issue in their corridors. But they had a couple of spaces, specifically lobbies, conference rooms, and only a few high visibility offices where they had hard ceilings, and they wanted to understand, do we want, especially for lobby conference rooms, do we want new fixtures where they're going to have a nicer look, add to the aesthetic, and not just have they had, I believe, majority they're parabolic and some prismatic lenses that did not look the best, and some like the lenses were cracked, so they were considering already new fixtures. And it's a hard ceiling, so it's it's not necessarily your drop ceiling where you can just quickly push in one of those panels and boom, you're there. You have to find a good amount of where are the crawl spaces, where are the openings, where can or cannot I have access. And we're already putting Lutron Vive solution in the majority of this chemistry building. So we were talking about, hey, there is this emerging technology, luminaire level lighting control, and luckily enough, one of the fixture families that they were looking at for the projects, I believe it was the dye family from Axis Lighting, were compatible with the LLC module from Lutron. However, when we asked for a quote, we saw that to add the LLC module, there was going to be a $120 adder to the cost of the fixture, which understandably it's rather higher, but 3 years ago it was a very emerging technology, and the OEM partnerships that were being formed were just very new. So I'm sure that the conservative figure was just part of that, but obviously just eyes opened wide on the project managers. And I want to call out that they were HVAC project managers, in the sense of they just kept asking us, whatever the easiest, lowest lift and least expensive option to retrofit the lighting, please go for it. and again, wearing that hat and that mindset in the past was like, sure, anything to get this job done. But again, big part of it is, let's think about what we're leaving there for the tenants and how we're improving the lives that are there. The other option that once we saw that price tag of the adder for the LLC module was, it's like, hey, we might just leave the non-pleasantly looking fixtures there and go with these instant fit instant fit TLEDs that are dimmable if you use these Mark 7 ballast, and that was the proposed value engineering solution. It's like, hey, if LLC is too expensive, let's just go with dimming TLEDs and add some NOC controls, call it a day. So ultimately, we wanted to understand, if we're going to go with that TLED and NOC solution, like adding a load controller, some sensors, and then a couple of wall stations, what was it going to take? And when their electricians, so they had some in-house electricians, were doing their investigations, they found that they had some inconsistent wire structure, where some spaces had the 0 to 10 volt wires and the ceiling, some spaces did not. So they were going to have to add if they wanted that dimming capability. Some spaces needed rezoning in the sense that they had a couple of newer daylight zones, new fenestrations that they had in the building, and the lobbies. Some of them had a good amount of daylight, but they never had daylight sensors. So hey, we want to meet code. This is going to need to be rezoned, and adding to that labor cost. And just many of the fixtures we couldn't get access to in the ceiling because it was a hard ceiling and could not either find or could not open some of the entrances there. So we were just thinking, hey, we can go with a known expensive LLC option, or with a TLED and NOC option that would look like more expensive, but there were still a lot of unknown elements. They charged on and went with a TLED and NOC solution. more so because, hey, it's gonna, we believe it was still, even with the unknowns, it was gonna be the lower lift on cost. And a little bit on that, it's upfront cost should never scare anyone from implementing a good solution on a good project. If you're looking at the image, sure, it may seem that you're saving a lot of money for the project, but if what you're doing is ultimately ensuring that the fixtures are going to have more heat, you're reducing the life of that system that you're implementing. If you're not going to have good lighting quality, you're not going to have pleasantly looking fixtures, you're not doing anything for the people in that building. And just to save that money up front, you lose the opportunity to build on the IoT capabilities that LLC technologies can provide. So again, don't think of upfront costs or the simple payback as the only meaningful metrics. Think about the life of the product and the system. And that comes from a disconnect where you have very cost-focused stakeholders or implementers that, again, as I mentioned, focus on the upfront cost, don't want to overcomplicate a project in the sense of, hey, the customer doesn't need LLC, they just need, an LED lamp rather than fluorescence. We don't want to spend that much time figuring out how we're going to implement a complicated technological solution. But you see that disconnect between designers, building engineers saying, I can't remember the last time I spec'd or designed a project without a network lighting control, a luminaire level lighting control solution. And you have your savvier facility managers and even some of the professors were already calling out like, hey, I know lighting can be controlled by phones. Is that going to be coming? I need integrated solutions. So the idea is to bridge that disconnect. One of these more solid techniques or solutions for that disconnect is having a good lighting audit, in my opinion, in the set that it just sets the tone and gives you that perfect understanding of what is the benchmark of my building. Because if the lighting survey or study or audit is not done correctly, you don't know what you have in your building. That's going to impact those constructability assessments in the sense of how are we going to build something, make something, implement something efficiently or not without knowing what's actually there. And obviously, once you understand the calculations of that benchmark, you can definitely calculate a lot of different solutions and present your stakeholders with various options, whether it could be acceptable, better, the best option. And the idea is to tell the story on the end side of the longevity of the system, not just how quickly will it pay for itself. And then just a bit more on, hey, discuss custom waiting and longevity. Like if you're not implementing your lighting projects, you run the risk of running out of utility funding. You'll always continue to overspend on energy if you don't implement the better technologies. If you just go with a switched TLED, you'll even continue to overspend on energy and also on human capital, as you have to, your facility technicians are constantly looking to run at maintenance issues. And ultimately, you need to communicate why a technological solution, LLC, or more advanced, complicated solution is better for a building that's not going anywhere, to get that buy-in from stakeholders. And if it's always a question on that cost, you can look at different financing models, such like, subscription models like the energy efficiency as a service, or it's called lighting as a service, where owners don't necessarily pay upfront costs. Providers following the as a service model will pretty much take care of all the implementation and maintenance. And once you have the project or the retrofit project installed, you will realize a lot more energy savings. And from those savings, a portion of those savings will go as that subscription payment to the provider who ultimately financed the project. It ensures that owners remain cash flow positive and can reduce those worries of oh, the upfront costs are too high, or the simple payback is going to be like 10 years. It's never going to happen. So there are a lot of ways. If you have stakeholders that are thinking about these ways, awareness of additional financing models, or just awareness of, hey, let's ensure that we invest correctly today to get our benefits for the time to come. Wanted to call out any questions before I move on to the next section. How do you enhance the health of occupants? Living design upgrades and advanced lighting controls in the case of a large old office building. Ramohan, I appreciate that question. A little too extensive, and I'd rather move on, and I'll ensure I reach out and want to have a discussion offline on increasing the health of occupants, because that is a lot of what we want to talk about, and I just don't want to butcher an answer for it. Wanted to discuss, as we're talking about, hey, we want to ensure that we're using the right solutions in the right places, and we're talking a little bit about the luminaire level lighting control technologies. NEA, the Northwest Energy Efficiency Alliance, the beginning of this month released a case study where they have this 900 square foot room and the 9 fixtures. It used to be similar to one of my pilots, 1x4 2-lamp fluorescence. And what they studied in here is they actually procured 4 separate luminaire level lighting control systems, as well as what they call a redesigned system, which is actually just a zone-based network lighting control application. And the way they went about this, and what's interesting about this, I'm going to use our spotlight tool here. You're looking, hey, at implementation cost. A couple of these LLC systems were sold through distribution, so there was no need to go through a rep and get a large design specification cost. And you can tell, which system did have a little bit more of that design and rep involvement. And obviously, for the NLC zone-based system, it was definitely gone through a rep or a partner that had more of a hand in designing the space, so that can tell that story. And hey, what was that implementation cost for these systems that they looked at? Again, it's a great study that I'd encourage people to check out, and you can download it again in the handouts on the GoToWebinar dashboard on your right. Moving on. So wanted to also call out, hey, they experienced different implementation times. So you can see not necessarily that much of a different, and these are hours on the left-hand side here. And you can see it's like, hey, implementation time for either hardware programming and commissioning. And ultimately, you can see how each system performed in their saving. Just because it was a smaller sample size, we're looking at watts per square footage here, where hey, your systems are all providing a good amount of savings, all within 60-70% savings. The real interesting piece is looking at, hey, how do we differ the redesigned zone-based system from the LLC systems? And they have a beautiful chart at the end of the study where they estimate the annual savings, and they break them down on, hey, we're only looking at high-end trim. How do the systems compare? If they're looking at savings from the daylight occupancy sensors, and when we're looking at all control measures, it's good to note that the savings are pretty consistent. Yes, it's like about a 20% difference over all systems, but LLC and that zone-based redesigned system, they still provided that very solid savings. And LLC systems, you can see, hey, even went a bit beyond some of those NLC zone-based savings metrics. Never forget the human factor. There was a solid study and methodology and survey effort that if I go into explaining it, I would probably take 2 hours to try to understand it myself. But the conclusions are pretty solid, where the highest satisfaction from the majority of the occupants were when the luminaire level lighting control systems were tuned to IES standards. Overall brightness was found to be a little bit lower than expected. And that's not necessarily a bad thing, in the sense that you don't necessarily want a brighter space and be susceptible to that discomfort glare. And this too were kind of interesting, where the light was seen as both more calming but helped better focus. And at the task plane, your desk, a brighter luminance was reported. and there was no major satisfaction difference between your LLC and NLC system applications. Barring questions, we have reached the end of our content, so to say. We want to invite anyone in the audience, and if Shawn and Dan, if you guys can put in your webcams back on and come in with me here. I want to see if there's anyone in the audience brave enough to put in the chat, hey, I had a project, or join you guys. And if not, that's fine. As you can see, Shawn, Dan, myself, we can spark some solid discussion. So again, inviting anyone that may want to write in chat any questions, any project questions or stories that you may want to share. Because if not, I'll turn on my moderator facilitator hat on very quickly and ask questions here of these veterans and titans of industry. I'll give it like a 5 more seconds. And obviously, as we are discussing here for the next 10 minutes, you can always write in chat and comment on anything. So wanted to ask Shawn, Dan, any project that you're particularly proud of, an application you implemented, and bonus points if you can think of one that includes network lighting controls.
Well, there's a number of different projects. So we talked about, I mean, Shawn had talked about earlier those projects. He was talking about, I think, Pacific Place, where the budget would not allow them to have a separate lighting control system. They wanted to integrate it into the HVAC control system. And we see that kind of situation come down from time to time. Right. And the one thing you need to understand is that you're talking about two completely different methodologies of operating systems. One just turns systems on, off, checks temperature, checks the conditions of the space, turns it on, off. The other one is modifiable by the user and can be adjustable to the user. And you show that with the LLC methodology, where you have that ability to do that. But when you run into that situation where someone really wants to do that, there are ways in which you could take that project and just break. You can say, instead, let's go ahead and put in a control system, but we'll give you some access of a certain parts that we can have, so that we have an interoperability of those. And that would be, for example, the control system we used on University of Washington Bothell campus, the Research and Technology Building. That one, each of the classrooms has its own multi-scene controller in each classroom that's tied to not only to control on the wall, but it's also tied to the lecturer's screen, so he can connect through AV to it. So if he wants to start his presentation, he hits presentation button, the shades lower, the lighting dims, the projector comes on, the screen drops, and he can present. And when that system is standalone within that room, but it's tied to the overall campus, the overall control system of the building. And the HVAC sensors in that room are also, the occupancy sensor, I should say, is also controlling the HVAC for that room. So if someone enters, the lighting sensors say, hey, somebody's here. I'm going to bring it to just a lowest level setting so you can get across the room, do whatever you want. But it arms the HVAC system to know this says somebody might be coming in to use. So over a timeout period, that it says, okay, it's been longer than 4 minutes. I'm going to kick the temperature up and start rewarming this room up. So there's ways you can do that. And we gave all the areas that only needed time control, exterior lighting, main public area lighting. Those were ones where HVAC could set the schedule for those, so that because that's one they knew that they wanted to be able to control and not have to use 2 different programs. We let them have that, but everything else in the building was controlled by the lighting control system and was interfaced, but it was also interfaced to security. It was also interfaced to emergency systems and fire alarm. So if something happens, say, for example, someone pulls a blue box alarm on the campus, the within the vicinity of that building, the emergency lights in that building would come on for safety's sake. Same thing with fire alarm, and same thing for security. So you can interface systems more easily than you think, and those interfaces can be beneficial to the total control of a campus more so than what people have a tendency to be afraid of them, and you really shouldn't, because they've been doing it for such a long time on just simple systems like that you don't have to worry. What you want to stay away from is having a one program controlling everybody and everything system. Those never ever work. They don't, because it's different technologies trying to talk to one format. So
Oh man, so we do have a live question, and Dan actually wanted to go back to that. So I wanted to put a pin on that, because integration on the building systems is a hot topic these days. But question from a David Summers telling us, hey, we just installed 2,000 LLLC troughers. Had a lot of the tenants complaining about every imaginable thing. So setting the stage. So questions more so, hey, and Shawn, you kind of alluded to this. Do you suggest a training for every user on how to approach explaining these systems, or how do you approach explaining these systems to larger people in the simplest way possible?
So generally speaking, so 2,000 light fixtures, that's a project of some scale. Most projects that I've done have some level of network lighting controls. In fact, probably 80% of the projects I've done in my career have some level of what we would think of as network lighting controls. Now, the important part of how that interfaces with this question has to do with making sure that the end users, not just the building owner, not just the contractors, but not just the architects, that the building owners, building users have some level of understanding of what they can expect from the lighting control system. I mean, the time that I first discovered this many years ago, there had been a lighting retrofit at Lawrence High School in Lawrence, Massachusetts, where the ESCO that had done the retrofit had installed what they considered to be a hyper efficient solution, which was using lamb lighting. Those of you who have been around a while will know lamb lighting, hockey puck uplights. So 250 watt metal halide uplights in school classrooms. Yes, for the time they were using less energy than most school classrooms, which is fantastic, except you couldn't turn the lights off. Yeah. Because if you turn the lights off, then you have to wait 15 minutes before you could turn them back on again. So, you know, this would be an example of you know, telling people how the system works. It's a really bad way that the system works, but at least they would understand how that functions. So for the sake of that particular project, I would probably say, one, I would want to understand what the needs of the end users are. Two, I would want to make sure that the lighting control system is in fact meeting those needs. If not, then it should be set up properly to meet those needs. And number three, I would go ahead and either meet with them or at least put together a succinct two-pager that tells them exactly what they can expect, and very importantly, why. A lot of times that I find that if people understand why a lighting control system is doing what it's doing, either that's to meet visual needs, that's to meet task needs, or it's to meet energy goals. Once people understand why something is happening, they tend to accept it a lot more and tend to be supportive of it. So that's what I would suggest. Dan, back to you.
Well, there's another way to look at it too, because you know, when you're, and this goes to when you're looking at a system itself, and you have that situation where all of a sudden now you have a bunch of people complaining, or a bunch of people just saying they don't understand it. It does get back to Shawn saying you need to make sure that the people understand the use of that system itself, so that they can appreciate what its benefits are. They need to know what you know to a certain extent. You want to bury them in the minutia of all the complications of it, but you just want to say, here's what it does, and but you have to give them a safety switch. It's something that if everything gets too complicated, where's that one button that you can turn it on? There was a house, an estate that I did one time that I didn't do the control system. Somebody else did on it, but it was a sophisticated control system for its time. But the owner was an elderly gentleman, and it was his wife, who was fairly young, who decided that she wanted this fancy system in there. His office had a toggle switch, and that was it. He demanded that it be just that toggle switch.
Wow.
So after the building was built, had been running for about 3 months, something happened with the programming. There was a glitch, and in the middle of the night, the system just went completely down, just totally down. The only lights in the house that worked was the ones in his office where he had that little toggle switch. So what is your way of getting them to a position where if by chance something happens, they still are able to give themselves light without having to call in a programmer to redo the system and get it back to life? So I'm thinking that another project that we did, we had it was combined with one of those systems that wanted to touch with a touch screen to control everything in a space. And so when we installed it, what I had instructed my guys to do is have a master override controller from the lighting manufacturer, control manufacturer, put in a room down where the estate manager could easily get to that. We showed him how to use it to get to it. That digital control touchscreen that they had used everywhere else, that integrated everything in the room to the TV set, this big screen, everything. Once again, they always happen in the middle of the night, like 2 o'clock in the morning. Every light in the entire home went on full bright, and they couldn't shut it off no matter what. So they called the estate manager, and the estate manager reminded, go downstairs to this closet, open it up. There's a panel there. Hit button number 1 and everything, and they hit button number 1, and it brought the whole lighting control system back down to at least the usable point. So then the next morning they could have the programmer come and fix his problems. But it's that situation where you have to be able to give them some way where a user can, in case of emergency, it's that hand-off auto switch that says emergency, you got to hit that button. Give them something to work with so that you don't leave them in a lurch. And then that will help to build confidence in them in the long run of getting used to that, because everybody's worried about those things happening.
No, thanks a lot, Dan, Shawn, and thanks a lot for sharing a lot of your knowledge, both from what went wrong, lesson learned projects, and both projects were really rocked it. Always worth tapping into wealth of knowledge. So again, thank you all. A couple of things to close out here. As always, we are continuing our series of education. Go to our Lighting Design Lab website to see the upcoming delivery dates and topics. You can always continue to engage with us by emailing us, our website, and from our presenters today, myself, Shawn, and Dan Salinas, contact information on top. Yep. Thanks again to all our sponsors in the Northwest Energy Efficiency Alliance for sponsoring this webinar. From all of us at the lab, that is all, folks.
Thanks.
Thank you for joining us.